Okay, now let's go on to some of the safety features. But before we go into it, let us look at how our circuit is connected first. Okay, we have electrical appliances connected on 3 wires. That's why we always see the 3-pin plug. Okay, there's a live wire, the earth wire, and the neutral wire. Take note, the live wire is connected to the main supply and is responsible for drawing current from it. Okay, so the current actually flows in. Okay, current flows in from the main. Okay, then the neutral is the one, okay, where the current goes out. Okay, current flows out. Okay, it's there to complete the circuit. So you know that current must come in and current must go out. And the last one, we have the earth wire, which is connected to the ground. You will see each for the live and the neutral is to complete the circuit. For the earth wire, you will see its function later on. Okay, so this is the basics that you need to know with regards to a simple circuit that we have at home. First safety feature that we have is actually a circuit breaker. So how does it work? Okay, this is actually a safety device that switches off the electrical supply when there is, what's the condition? When there's excessive current in the circuit. So for example, at home, okay, we have it at home when you know that sometimes there's a blackout. Okay, you know that blackout is actually caused by the circuit breaker. Okay, where the switch switches off. We say that it has tripped. Okay, we say that there's a trip in the circuit. So what we'll do is we'll flick back the main switch over here. Okay, and things are fine. But when does it trip? Okay, the key is because there's excessive current in the circuit. One of your appliances might be spoiled, and that's why it might be drawing excessive current due to short circuit. Okay, due to short circuit. So take note of these terms. The next one that we have, safety feature, is what we call the fuse. Okay, how do you draw the fuse in a circuit symbol? It's actually it looks similar to a resistor, just that there's a line going through the rectangle. Same thing, this helps to prevent excessive current flowing through the appliance. Okay, now what is actually the key here? How does it work? You can see here that there's a very thin piece of wire here, thin wire in this glass tube. Okay, thin wire over here in this glass tube. What happens when the current is greater than its rated value? Okay, the wires will become hot and it will melt. So when the current is greater than its value that's needed, it will hot and melt. Okay, so when it melts, it creates an open circuit. So then your appliance cannot be used anymore unless you change the fuse. So the fuse actually helps to prevent excessive current flow, and this actually prevents damage. To the appliance. Okay, appliance. So this is the function of your fuse. Now, a fuse that we normally have at home is also normally connected to a live wire, and it has specific rating. Okay, it's not like chapalang anyhow. Okay, there's fixed ratings: 3 ampere, 5 ampere, 13 ampere, and so on and so forth. How do we choose the rating? Okay, we'll see later on over here. But first, let's see how it works again. Let's just a reminder, just a recap. The current from main supplies, when it exceeds the rating, the fuse will become hot and it will melt. Okay, this breaks the circuit, or it causes the circuit to be open, and this prevents the overflow of current that could cause fire. So one of the thing here is that excessive current causes fire. So when you can prevent this overflow, you will prevent the fire. How do we choose the fuse? So the fuse should always have a current rating just slightly higher than the current an electrical appliance will use. For example, in the lighting circuit, it uses 4 ampere. Right, the lighting circuit uses 4 ampere. So what is the rating of fuse do we use? We will use slightly higher. So if it's 4 ampere, we'll use 5 ampere as the fuse. Okay, if we use 3 ampere, the circuit will never work because the fuse will always melt, as 4 ampere is higher than 3 ampere, and so it will not work. Okay, it will not work at all. So the fuse, that's how it works. Okay, the next 60 features that we have is actually your switch. Most of you are very familiar with the switch. What it does is disconnects the high voltage from an appliances. Because where does the 240 volts come in? It's from the live wire. The current comes in from the live wire. So when you put a switch at the live wire, when you switch it off, it disconnects the high voltage from the appliance. So it is safe for us to touch the casing or touch the appliance. Okay, we do not need to worry about it. Okay, now if the switch is fitted to the neutral wire, the problem will come in because the current from the mains will still flow through the metal casing even when the switch is open. Okay, this is interesting here, even when the switch is open. Why? The current will come in from the live wire, and because let's say it flows through the metal casing, you complete the circuit by bringing the current down to earth. Okay, large current will flow through the person to the earth, causing a nasty electric shock. So take note, if you put it at a neutral wire, it's a no-go. Switch should always be placed at the live wire. So do take note of this. Okay, do take note of this. So switch placed at the live wire, it disconnects the high voltage from the appliance. But if you put it at neutral, the current will still flow even when the switch is on. So you must be careful. Next one, we got a fuse plug. Okay, a fuse plug is actually used to connect appliances to the main supply via the power socket. This one is the one that we always see. The plug here, it has a fuse. Okay, we call it also our 3-pin plug that we always see. Now, this cartridge fuse that we see here, it works exactly the same as the fuse. Okay, from the name, you know that it is a fuse. So what it does, it prevents excessive current from flowing through. Okay, when excessive current flows, it will blow and break the circuit and current stop flowing. So what this does is, okay, prevents excessive flow of current. Okay, prevent excessive current from flowing in the appliance. So this is what your fuse plug do. Okay, actually it's just a fuse put into a plug. Now the last one, we got an earth wire. Take note, the earth wire is marked yellow and green. Okay, it's a low resistance wire usually connected to the metal casing. So how does it work? Okay, so for example, when we have when the wire, let's say the live wire here, touches the metal casing, okay, if we do not have the earth wire present, live wire touch the casing becomes live, and the guy touches it, current will flow through the man, and the man will get an electric shock. But when there's an earth wire, the earth wire is connected to the metal casing. Okay, earth wire is connected to the metal casing. So same thing, when the live wire here accidentally something goes wrong and then it's connected to the metal casing, the metal casing becomes live, but the current actually is drawn away by the earth wire. The current is drawn away by the earth wire. Okay, so the earth wire prevents the user from getting electric shock because it diverts the large current to the ground, okay, when there's an electrical fault. So take note, that's an important term here that you must know. Okay, so please remember this is how the earth wire function because it is a low resistance wire. So when the current touches, when it's in contact with any current, it will direct the current away to the ground. Okay, that's how your earthing or your earth wire works. Looking at this yellow and green thing here, I realized that you must remember the diagram over here. You must remember the 3 components here. Live wire, what color is it? Live wire is brown in color. So take note, they will test you. They'll ask you what's the color of a live wire. Okay, for neutral, what's the color of it? You know that it is blue. Okay, let's use a blue pen here to make it. Okay, blue wire. Okay, this is for your neutral wire. neutral is blue, and the last one that you have is the earth wire. It is yellow and green. Okay, I'll use a green here. So you can see there's two wires, yellow and green, interconnected to the earth wire. Yellow/green over here. Cartridge fuse is connected to the live because that's where the current flows in from. So as you can see here, okay, this is what you need to remember. Earth is yellow-green, neutral is blue, live is brown. Now this marks the end of the chapter on electricity. Okay, if you have any questions, do make sure that you ask your teachers. Okay, this chapter is very much applicable to our real life, so do not forget to focus on it, and I mean not say focus on it, but to look at it more, okay, because it's going to help you as to how you're going to apply it in your life.